Semiconductor Manufacturing Process, informed by IEG. The first process of making semiconductor is to design the wafer. After dissolving silicone extracted from sand and hardening silicone solution, it makes a silicone pillar and cut it thin to make a circle plate. It is an important process to create core materials for semiconductor production. The created materials are moved to the next process. The second process is the oxidation process. It is a process to protect the product from contamination and impurities. For this, oxygen reacts on the wafer surface to form an oxide film. The third process is the photo process. After removing impurities from the surface by cleaning the wafer cleanly, apply a thin and even layer of photoresist on the wafer surface. A photoresist, a sensitive material to light, is used to form patterns during the exposure process. The main goal of this process is applied with flat thickness throughout the wafer. It ensures an accurate pattern transfer in the subsequent process. Next, the exposure process is performed to print the desired pattern on the photoresist. The exposure process, simply speaking, transfers ultraviolet rays to the wafer through a mask. It is the step forming a pattern on the photoresist physically and chemically. The next step, etching, is on the wafer surface based on the pattern formed with the photoresist. Removing materials using a mask to form a circuit pattern. The final step of the photo process is the strip. It is the process of removing the photoresist from the wafer surface completely. It makes a wafer cleaned and prepares for additional processes. The fourth process is the etching process. The etching process is one of the important processes used in semiconductor manufacturing. This is the process to form the desired pattern by removing unnecessary materials. It uses chemical or physical methods to remove unnecessary materials. Mainly used methods include dry etching and wet etching. Each uses plasma or liquid solution to treat wafer surface. Through this process, circuit patterns can be formed precisely. It plays a very crucial role in semiconductor manufacturing. Once processing is completed, remove the mask used for protective purposes as needed. Ultimately, you will obtain a product with the desired design. This is regarded as an essential step in semiconductor manufacturing. The next process is the wet process. The wet process is to treat the wafer surface by using a liquid solution. It is the process of forming the desired pattern. It is mainly achieved through chemical reaction such as oxidation and corrosion. By forming oxide on the wafer surface or removing specific areas to create patterns. Wet processes generally create precise mask patterns or it is used for purposes such as controlling the layers of semiconductor chips etc. Through this, various functions required in semiconductor manufacturing can be implemented. The sixth process is the ion implantation process. Ion implantation is used to change or control the properties of semiconductor devices. A high-energy ion beam collides with the wafer surface and the ions penetrate inside the wafer. It changes electrical properties by introducing defects or introducing positive or negative ions. Through this, the electrical characteristics of the semiconductor device can be modified or certain functions can be enhanced. The next step is the etch process. To form a specific pattern or structure on the surface of a semiconductor wafer, it serves to protect necessary parts. Generally, after protection, using a mask or resist, it treats the surface of the wafer using chemical methods such as oxidation or corrosion. Through this process, unprotected areas are removed to form the desired pattern. The etch process forms various components of semiconductor chips. It plays an important role in improving the function of semiconductor devices. The packaging process is one of the final steps in the semiconductor manufacturing process. This is the process of protecting the completed semiconductor chip and adding functions. In this step, to protect semiconductor chip into a special package or a case, a silicon chip is installing. Through this, semiconductor products are protected from the external environment. Finally, the product is completed.